Start recording. Okay, here we go. Hey, we're on BioMolecules lesson quattro. Big question. How is eating candy or running related to enzymes? Guys, we have put in some work to get here. Started out with chemistry to understand that all of biology is made of atoms. All living things are made of atoms. Biology is about bio. It's about life. Bio means life. And we have now gotten to a point where we are about to talk about biological molecules. You now have, hopefully, the categories in your brain of monomers and polymers and enzymes. And so we are now, and you have chemistry, that there are molecules that are made of atoms. So we are now going to talk about biological molecules today. And the very first biomolecule we're going to talk about are called carbohydrates. Okay, so biomolecules, lesson 4 is about the first biomolecule. There are going to be 4 of them. The first biomolecule, the carbohydrates. And so let's get into it. We're actually going to start with a PowerPoint. And so let me push number 4 here. And then let me move this computer over here. Let me hit OK on this button and hit the slideshow button and stand in the right place. And here we go, carbohydrates. So what is a carbohydrate? You are a middle schooler. You've probably heard of carbohydrates before. I just ate a bunch of carbohydrates for dinner in the form of bread and pizza dough, and they tend to make you thirsty. Here's a few examples of carbohydrates. Sugar. Sugar is the most basic carbohydrate. Honey is a carbohydrate. It's full of sugar. So sugar comes from plants. Honey comes from bees, which eat plants. Rice comes from plants. Bread comes from dogs. Just kidding. Corn. Are you familiar with corn? It has the juice. It's a big lump with knobs. Okay, we need to go look at the corn boy immediately. The corn song. If you have not heard the corn song yet, this is the hottest thing since 1 month ago. Wait, when did this come out? 20 million views in 1 month, guys. This is the biggest thing going on in the world. You know, forget about the Russian war and the presidential or the governor's election. The corn song. Here it is. Crank this thing.
For me, I really like corn.
What do you like about corn?
It's corn. A big fluffy nut. It has the juice.
It has the juice.
I can't imagine a more beautiful thing. It's corn. I can tell you all about it. I mean, look at this thing. When I tried it with butter, everything changed.
When he tried it with butter, everything changed. Okay, so this old guy in the picture here, he's like 25 probably. He makes videos of people talking and he auto-tunes them. So this kid loves corn and he is now known for telling this reporter guy that corn has the juice. Now, this little guy is actually a genius. So let me see. I have a screenshot of pop can ingredients. I don't know if you know this, but let's open this in a new tab. Oh man, okay, here we go. Okay, so, oh, I'm so good at using a computer today. I am a robot. Do not, no, I don't want this. Okay, I'm gonna right click, I'm gonna open image in new tab. Okay, so this nutrition label, let's go Control plus. Okay, we're gonna zoom in on this sucker, and then we're gonna push our, wrong thing, we're gonna push our pencil, okay? And right here, when you look at the nutrition facts of a label, okay, first thing they put in soda, carbonated water. So it's water that's bubbling, okay? So that's the number 1 ingredient. They go in the order of what the most is. So the number 1 ingredient in pop is carbonated water. The number 2 ingredient in pop, high fructose, that's a sugar, fructose. Notice the ose, we're going to talk about that today. High fructose corn syrup. Syrup is like thick liquid sugar. And so this little man is a genius, guys. He's singing about how corn has the juice. Corn actually is the juice. It's where we get the main ingredient that we put into the sweetest drink that all humans love. Let's just listen to a little more. If he was surrounded by corn, he would eat all of it. It's a lump with a knob. I don't know what he's talking about at this point. Okay, so anyway, you need to go watch the Corn Boy sing his song. It's a great song. And he is right. Corn has the juice. It is a carbohydrate-rich food. And there's songs about it, and there's t-shirts about it. It is all the rage. Okay, now let's keep going. Oh, there's one more video. Oh, I didn't bring it up. Oh, here we go. When we're talking about carbohydrates, they come from plants, biology, study of life. And there's the kitchen sink with Elon Musk. What were we going to look at? Corn. What are those things called? They have them in hot places with lots of water. Sugarcane. Sugarcane. How it's made, I think is what I was going to watch with you. Is this the one? No. Maybe? Did I watch this like 3? Yes. Okay. So we're going to watch the first 2 minutes of this video. This is super interesting. So like, everybody's familiar with sugar, like this sugar right here, okay? Like growing up, you think this is sugar. Well, where does that stuff come from? Okay? It comes from plants. So how do you get sugar? You have to get it from a plant. And like probably like 300 years ago, somebody started figuring out a way to make sugar that looks like this from a plant that actually looks like this. So, right, let's click it. Boom. So this is sugarcane. So if you've ever been to Hawaii, you've seen this maybe growing. This is something they grow in Hawaii. You have to be in a very warm location. I mean, look how tall that is. That's a tractor that we see in Oregon cutting hay. It's been modified to cut sugarcane in Hawaii, or I think this is in Australia where they're doing this. And so it's going to be in places where it rains a lot. And where they can fertilize a lot, because you're going to need a lot of fertilizer to get this much growth out of anything. And so they're going to show you a little bit of how they process sugar cane. So it's like long canes that are sugar rich. Oh, whoops, I need to do that. And so it's pretty interesting. We'll only watch about 1.5 minutes of this, and I'll probably stop it a couple times. But you can see it's just like a giant lawnmower blade that's going to cut this.
These machines harvest the cane by cutting it at the base. The heavier lengths of cane drop into the base of a conveyor, which feeds them into the transport bin that follows alongside. At the mill, trucks empty their load onto a receiving table. It feeds a belt conveyor that takes the cane through 2 separate washes. The cane must be as clean as possible for extracting the juice.
That's your Snickers bar, right there. There's your Snickers bar, okay? Like, oh, I love candy. That's your candy right there, okay? All the candy that you eat is either corn syrup, that's often the main ingredient in candy, or sugar cane down there. So how does that get turned into what they use to make candy? Delicious.
But first, the cane's hard structure is broken down inside this crusher, where rotating hammers...
So I don't know if you heard that, but they crush it. So they take the sugar cane. The sugar cane is rich in sugar. So imagine like it's this cane, and you could like lick it and be like, oh, that's kind of sweet. And like hundreds of years ago, somebody's like, hey, if we crush this up and then we soak it, we can get like this liquid juice to come out of it. And so they're crushing it.
The conveyor loads it into a milling tandem designed to extract the sweet juice from the crushed cane.
It says we're going to extract the sweet juice. So now they're crushing up. You can see a little bit of sugar in there maybe.
In this milling tandem, the cane passes through a series of 5 or more consecutive mills.
So they're milling it, which means they're grinding it into a powder. And they're washing it and turning it into a juice.
The milling tandem and diverts into a channel away from the bagasse, the dry pulp that remains after extracting the juice.
And now they're kind of removing the fiber of it and just getting the liquid portion that's got all the sugar in it to flow away.
A worker supervises the operation at each of the mills. A vat vat collects the
Look at that. That looks so gross, doesn't it? So that right there, this is what's got all the sugar in it now that they're going to use to make that nice, beautiful white sugar. That does not look good. Like, I wouldn't think that would be a good idea to put that in my mouth.
flows from the top and bottom of the mills.
This is cool.
Now that the juice is extracted from the sugar cane, it's time to...
Okay, so what, and this is where we're going to stop. I'll zoom to the end because there's a lot of processes. So processing is a really interesting idea. How do I take raw materials, okay, that's a sugar cane that grows, and so like if I were to lick this part, it'd probably have kind of a sweet taste to it. And so somebody's like, man, we could really make something out of this. And then they learned, oh, we can grind it up, and then we can mix it with water, and then we can make juice out of it, you know? And then somebody else is like, well, what if we let the juice all dry up, it turns into a crystal, and then we can grind that crystal up to a powder, and it's, you know, powdered sugar, you know? And then, well, what if we do it with millions of pounds a year, and we produce lots and lots of sugar, and then we sell it to the whole world? And so if you zoom to the very end here, that's what they do in this factory, and you can see, you can go watch this whole video if you Google what I Googled at the beginning. And there's a whole process, and they dry it, and eventually, this is pretty cool, look at this. At the end, they're literally, I'll mute it so I can talk while it's playing, but they're literally, there's I think 1,000 or 2,000 pounds in each bag there, and then they're gonna cut it, so they you know, kind of mass produce it, and then they're gonna cut their bag open and drain it at the end, and it gets white and pure, and they bleach it, and they do all this cool stuff to it in this factory, and then they actually separate it into little bags at the very end. And there you go. There's the little bags of, you know, 5 pounds of sugar per bag, and those get shipped off to get sold at the grocery store. So that's pretty cool. But it started with raw sugar cane. Okay, so carbohydrates are mostly sugars. So let me get back to the end of this thing. We're just about done here. You know, there's all these other things, rice and bread and corn but then there's a couple other things carbohydrates do. They're also structural. So a tree is made of carbohydrates, which is not sweet, and you don't usually think of eating it. Okay, and also this is a picture of an ant from an electron microscope. You can kind of see the structure of his exoskeleton really well. The exoskeleton of bugs is made of a funny sugar called chitin, and that's a sugar as well. So mostly you think of sugar as something you eat, but also the bark of trees, you know, wood is sugar, and then also the exoskeleton of bugs is sugar. So, and really longer chains of sugars, polymers of sugars, called carbohydrates. So, so anyway, there's sugars. So now let's get into the notes a little bit. Not just sugars, but carbohydrates. So now let's get into the notes a little bit and get a little more scientific about understanding sugars or carbohydrates, okay? And so there are 3 basic categories of carbohydrates that I want you to understand today. The first one, so 3 types of carbohydrates. And sugars are just the monomers of carbohydrates. I just went and grabbed a pen. Here's a better pen. Okay, first type are called monosaccharides. Okay, so S-A-C-C-H-A-R-I-D-E-S. Wow, that is a big word. Monosaccharides, okay? And mono actually means one, okay? And saccharide, the word saccharide, I believe is Latin. Maybe it's Greek, I'm not sure. And it means sugar, okay? So it means one sugar. Now the next one is going to be called a disaccharide. And the last one is going to be a polysaccharide. And I'll tell you what those 2 words mean, the poly and the di, in a second, okay? Now I got to grab my other bag of notes here. Hold on one second. Okay, here we go. Got to get some of these details straight. All right, so monosaccharides are single sugars. So glucose, for example. So they're 6-carbon glucose. So it has 6 carbons. It has a single oxygen in one of its ring locations. And then it has carbon everywhere else. And then it has 1 extra carbon that sticks up. And so we learned about this in the chemistry unit. So it's got 6 carbons. There's another one. So I'm going to just write 6 carbons. Okay, and 6 carbons, and you've got glucose that fits into that category. And then there's another category of sugars, monomers, that are single ring sugars, and that would be the 5-carbon sugars. And there's lots of 6-carbon sugars. There's another one called galactose, and yeah, I don't know. There's not a ton of them that I'm aware of. I mean, I know there's a bunch, but there's not a lot that are in my head. So glucose, galactose, there's probably 15 of them, but I mean, there's not a lot that actually seem that relevant. Then there's 5-carbon sugars. An example of this is ribose, okay? And that'll be important when we study DNA. So it's going to be a lot like glucose, except it's going to be the shape of a pentagon instead of a hexagon, which I've kind of screwed up drawing now. And it's going to have a 6. So you can count. There's actually a right way to count this, and I don't remember what it is, but say it's like this: 1, 2, 3, 4, 5. There's a very organized way that they count the carbons. I don't remember if it starts here, but anyway, these are a lot of details you don't really need to know. But anyway, hexagon. Remember, if it's a hexagon, it's a sugar, and if it's a pentagon, it's a sugar. That shape is what you'll see in your workbook. Okay. Now the disaccharides, a couple that you may have heard of. So you've heard of glucose. You probably haven't heard of ribose until right now. But notice that it ends in ose. Okay. So you got the single sugar molecules. Those are called, once again, monosaccharides. Okay. And I won't go there yet. Okay. Now let's go to the disaccharides. Okay. There's lactose. Now you may have heard of this, lactose. Some people are lactose intolerant. So lactose is made of 2 6-carbon sugars. And so I'm just going to draw a hexagon now instead of drawing all the carbons. And they are connected by an oxygen bond. And they would look like this. So a disaccharide is when there's 2 sugars. So di is for 2. So disaccharide, 2 sugars. And I think we'll just stop there. Let me go look in the workbook really quick. Sorry, I'm Mr. Prepared tonight. Oh, I did put sucrose in there. Okay, so another example of so table sugar is actually sucrose. So if you eat at a fancy restaurant and they have that white packet of sugar there, that's usually, I think, sucrose. So it's still pretty sweet. Lactose is milk sugar. It's the sugar that's actually found in milk. Okay, sorry, one more thing. Okay, and so sucrose is a 6-carbon sugar connected to a 5-carbon sugar. These are a lot of details. I'm sorry, guys. I gotta hustle here. Okay, so a couple of disaccharides, lactose and sucrose. And then a polysaccharide is when you get a really long chain of sugars. Okay, so say you have like a whole bunch of monomers connected together like this. This is called a polysaccharide. And a lot of times the polysaccharides will start to branch off like in multiple branches, and so like you'll have like, you know, just like a tree branch, comes off, and then it comes off again. So you get like a branch here, and then a branch there, and another branch. Okay, so a polysaccharide, poly means many. Okay, all right. So 3 types of carbohydrates. You've got monosaccharides, disaccharides, which I'm sure you're thrilled to write the word saccharide 6 times, and polysaccharide. And remember that saccharide means sugar. Okay? So you can have a single sugar molecule, a single hexagon, you can have two hexagons, or you can have long chains of hexagons. Okay? And so, some examples of polysaccharides include one that I'm going to tell you about in a second called, I'm going to put the word example here. And examples include glycogen and cellulose. And I think that's about it. Cellulose is the one that's in trees. Okay. I also mentioned the word chitin, which is the one that's in exoskeletons. I'm not going to put that on your test or anything, but in case you really wanted to know that. Okay, that's a lot of information. Sorry. Okay, now here's something else I want you to notice. Os. Okay, notice os. Okay, os, os. Sugars always end in os. So sugars usually end with these, and it's not always. So like chitin doesn't end with os, but it's usually sugars end with these three letters, os. Okay, and that's super confusing because as you're going to see in just a second, and maybe you've seen it a little bit already, enzymes almost always end in ase. So let me tell you a funny story. I grew up with a friend, and his name was Dewey. Okay, and Dewey was lactose intolerant. And like I just told you a second ago, lactose is milk sugar. So mammals are creatures that have mammary glands. So cows have mammary glands, and so they have milk. Okay, mammary glands make milk. Mammary glands are what come with nipples. Okay, and so cows have nipples, mice have nipples, even whales have nipples, and only mammals have nipples, and only mammals have milk. Pretty much. I think there might be one other kind of animal called a monotreme that has nipples, or not nipples, but milk. And maybe kangaroos. I'm not sure if kangaroos have nipples. They don't have nipples, but they might have something like milk. So anyway, milk comes with its own unique sugar called lactose. So when you drink a cow's milk, you're drinking a special sugar called lactose. And you produce an enzyme inside of yourself that will allow you to break that bond. Look back at our notes. Not wanting to work. So look back at our notes, still not wanting to work. What am I doing wrong here, computer? Maybe I'm pushing the wrong button. Maybe my computer just doesn't want to work. Okay, look back at our notes. And lactose, okay? Lactose has a special bond right here. So you need a special enzyme. Okay, remember our notes? Enzymes have to fit just right to break a bond. So you have to have a very special enzyme to break the lactose bond. It has to have the right shape to fit two hexagons so it can break this bond right here. So, my buddy Dewey, I would go over to his house. I was probably like a 5th grader. And Dewey loved ice cream, but Dewey was lactose intolerant. And so what happens is if you're lactose intolerant, the sugar that would normally get broken apart, when it gets broken apart in your stomach, actually it doesn't get broken apart till your intestines, which come after your stomach. When it gets broken apart in your intestines, once it gets broken apart, it goes through your intestines into your blood, and then it goes to your body where it's supposed to be, and you absorb it and use it in your body. But if it doesn't get broken apart, your body doesn't absorb it, it just keeps going. And it goes past your intestine, your small intestine, to a place called your colon. And in your colon, there are these things that live called bacteria, good bacteria. And good bacteria normally don't get to eat delicious things like lactose. But when they do, they have a fiesta. They have a party. And when bacteria have a party, they make gas. And they make lots and lots and lots of gas. And Dewey, it seemed like whenever I was at Dewey's house, it was either pizza or ice cream. And pizza has cheese and ice cream has milk, right? And cheese and milk have lactose. And so Dewey would always eat and drink milk and eat pizza. And then we'd be laying in his bunk beds at night, going to sleep with the sleepover. And he would have these farts that were so loud and they smelled so bad because he was lactose intolerant. And the lactose got to his colon and the fiesta happened in his colon and the bacteria had a great time. And I always remember like not understanding why Dewey had the most powerful farts in the world. And then in college, learning about lactose and learning about like, oh, you have a colon and the bacteria in your colon do really well if you eat lactose and don't have the enzyme to digest lactose. So the enzyme that digests lactose is called lactase. So this is why I put on my notes, man, my dumb computer today. This is why I put on my notes, don't confuse enzymes and sugars, okay? So here's our first example, real world example of enzymes. Okay, it's lactose and lactase, okay? So, and remember this cycle with the energy? Well, there's enzymes involved. So, when you have lactose, you have a high energy molecule, lactose, okay? Ose means it's a sugar, okay? The high energy sugar, lactose, I'm even going to help you out here. The high energy sugar, lactose, needs a special enzyme to break it down, to release its energy and turn it into something else. That enzyme is called lactase. That's enough to make you lose your mind, okay? Ose, sugar, ase, enzyme. So lactose can be broken down by lactase, and when it breaks it down, it turns it into, this is actually glucose, okay? And then this sugar is called galactase, galactase. And so you literally break lactose into glucose, 1 6-carbon sugar, plus galactase. It's kind of a lot like Legos. You'd be just breaking one thing into two things. Okay, lactose gets broken into glucose and galactase by lactase. Okay, and this happens in a human gut. Okay, now also in mammary tissue in a cow or even in a human, anybody who makes milk, which is amazing. Like, there's a special kind of tissue that only cows and nursing mothers have. It's called mammary tissue, and it can take glucose and galactase with a special enzyme that's called, I have to think about this for a second. What is that enzyme called? It's called lactose synthase. Lactose synthase. Okay? Lactose synthase can create lactose from glucose and galactase. Okay, now are you with me here? Let's go over this again. Nothing is working today. I think my keyboard is dead. Okay, turn on this keyboard. Where are you, keyboard? Okay, so you've got lactose, high energy. You can break it down into glucose and galactose. And you have to use the enzyme lactase to do it. If you want to go back to lactose again, you have to use lactose synthase. And lactose synthase can put them back together and put them back on top. Okay? It's called lactose synthase because to synthesize something is to create it. It is to put it together. To synthesize is to create. So like synthetic, like remember we learned that Kevlar is synthetic. Synthetic means created by people. So synthetic Kevlar, it's not natural, it's synthetic. It was created by people. To synthesize is to create. Okay? So let's go to the words now. Okay? So the sugar found in milk is called lactose. And the enzyme for breaking it down is called lactase. Okay? The enzyme only made in new mothers that makes lactose is called lactose synthase. And a fancy science word that means create is synthesize. All right. Now, one more example. Okay, you guys are like, holy moly, Johnny, how long is this lesson today? Well, so far it is 30 minutes. We got one more example to do, okay? Another example is glycogen. I told you that a long chain of sugars, one example is glycogen, okay? So let's write the word glycogen here, Glycogen, okay? So I'm just gonna write glycogen example. Okay, I'm just going to write glycogen right there. So glycogen. So this one's super relevant to anyone who's interested in sports. Okay, so you eat 3 times a day. You can actually go for like about a day and a half without eating anything and still have totally normal amount of sugar in your body. And then really you can go for about 3 days maybe. And then after about 3 days of fasting, for most of us who've never done that though, like about 6 hours of fasting is like, holy cow, my blood sugar levels are super low. So when you eat a whole bunch of sugar, your blood sugar goes up. Okay, so we have a pretty stable level of sugar in our blood all the time. So when you start pounding down the Skittles, your blood sugar starts to rise, and your body has a lot of really cool systems to say, hey, we need to keep this more constant. And so your body starts absorbing all the sugar in your blood into your muscle tissue and into your liver that's right below your lungs. And so it kind of keeps everything constant. Once you have all this sugar going into your muscles, you need to do something with it. You take all those individual sugars, plump, 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 start building chains of sugars. Chains of sugars are called glycogen. Okay, so let's put that down because that's pretty easy to remember. The glucose storage chain that's found in your liver and your muscles is called glycogen. Okay? And there's an enzyme that has to build it. Okay? So this one's actually easier than lactose. When you get a whole bunch of glucose showing up, you need to turn it into glycogen, like glucoses. I'm going to put an S on that. Okay? When you get a bunch of glucoses showing up, you need to build a chain. Okay? And the enzyme that does that is called glycogen synthase. Am I right? No. Yes. Yes, that's right. Glycogen synthase. So once again, here I'm helping you out. Remember, synthesize, oh, I missed an N there. S-Y-N. I'm not even putting it in the right place. It's like 10 o'clock at night, guys. I'm sorry. Okay, glycogen synthase is an enzyme that synthesizes glycogen. And then there's an enzyme that will break, well, let's not go there yet. Okay, so let's review that. Okay, so you are cramming Skittles. Skittles. I was eating some Skittles today. They're good. Okay, and your blood sugar starts to skyrocket. Okay, so your body's like, get all this sugar out of the blood. It's sort of like when the principal of the school is like, there's too many kids in the hallway, send them all to the classrooms. Okay, and so all the Skittles, all the sugar, all the glucose from the Skittles goes into the liver, goes into the muscles, and then the teacher is like, there's too many kids in the classroom. Stack them all on top of each other. You ever stack chairs? Stack. Start stacking kids. Stack. Make a long chain of kids, except it's not kids, it's sugar molecules. Stack. And you get this nice long chain of sugars, and it's called glycogen. Okay? Now, let's say you don't eat for 3 days. No, it doesn't take that long. Okay? Or let's say you're exercising. Okay? You go for a run. Like I used to run. Not so much anymore. Can you tell? Start running, you hit about a mile, and your blood sugars are starting to go. Okay, you get to 4 miles, 5 miles, the blood sugars are really dropping, and so at some point in there, a signal gets to your muscles that says, "Hey, we need more sugar in the blood," and so your muscles are like, start pulling glucoses off the chain and start throwing them back into the bloodstream, and so there's an enzyme that starts chopping glucoses off of the long chain of glycogen and throwing them back into the bloodstream. That enzyme is called glycogen phosphatase. and it just cut. And I don't know why it's called phosphatase. Probably uses a phosphate to cut each glucose off, okay? So let's go back to the notes and we'll write down our last enzyme. Okay, so the enzyme that does this is glycogen phosphatase. Okay, glycogen phosphatase will cut the glycogen molecules, cut, and break the sugars off and throw the glucoses back into the blood. Okay, so the enzyme that makes glycogen is glycogen synthase. You see what I'm writing? Glycogen synthase. Okay, and the enzyme that breaks down glycogen is glycogen phosphatase. Okay, now that is a ton of words today. One of the biggest things that's in the workbook is actually, is it an enzyme or is it a sugar? Okay? And if you look back at the big question, how is eating candy or running related to enzymes? I guess it's that glycogen question is what I had in my mind. The lactose one, I feel like, as I just explained this for the first time to my camera, the lactose one is harder. And both of those are a little more complex. That's real biology, what I just explained to you. It's called biochemistry, and it's biology, and it's called physiology. So you take a class in high school called anatomy and physiology. That's real physiology I just explained to you. If it was a little overwhelming, like, oh, that's a lot. Like, I'm trying to take big ideas and explain them to middle schoolers. I don't think I did a perfect job right there. But it is 9:40 at night on Thursday night, and I have to post this by Friday morning at 8 a.m. So I'm going to post it. And if you're like, I didn't understand everything there, that's okay. I think the glycogen one was pretty accessible. If you know the word synthesis means create, I think you're in pretty good shape. If you learn that ose is sugar, if it ends in ose, it's a sugar. If it ends in ace, it's an enzyme. I think you're in pretty good shape. The workbook is going to help to kind of firm up some of these ideas. If you learned that a monosaccharide is a single hexagon sugar, if you learned that a disaccharide is a two hexagon sugar, and that a polysaccharide is a long chain of sugars, that's pretty good. Okay? There's a lot there today. Like, as I just look at this lesson, I think, ooh, that was a little more. I probably should have ditched maybe the lactose. It kind of feels to me like that was all necessary together. So do what you can with it, and don't feel bad if some days it's a little more and it takes a little longer. That's normal. And have a great day.